Good morning. It's Dr. Hope, and I read the surveys that I received, and I wanted to try to implement some of the things that you guys have suggested that might help you. Someone had asked for a video to show how to work out a problem similar to what was going to be on the quiz, like the step-by-step video. So I found one question in your book on page 360 that is similar to a question on your quiz. It's number 6. So the question says, in the preview for chapter 2, we presented a study showing that a woman shown in photograph was judged as less attractive when the photograph showed a visible tattoo compared to the same photograph with a tattoo removed. I'm going to set this down so I don't keep moving it. But just know where you can read along with me. I'm on number 6 here. Suppose a similar experiment is conducted as a repeated measure study. A sample of n equals 12 males looks at a set of 30 photographs of women and rates the attractiveness of each woman using a 5-point scale, with 5 being the most positive. One photograph appears twice in the set, once with a tattoo and once with the tattoo removed. So it's important to note here that they're only testing one photograph. One of the photographs with and without the tattoo. So you've only got two things that you're testing against each other, which tells you what? That you're going to need a t-test, not an ANOVA, because that's for more than 2. So you know you're going to need a t-test, and you know that it's going to be repeated measures because they're using the same photograph and repeating it with the same group of people, and using that photograph again with the same group of people with the tattoo and without the tattoo. Hope I didn't mess that up too bad. Hope you know what I mean. So anyways, for each participant, the researcher records the difference between the 2 ratings of the same photograph. On average, the photograph without the tattoo is rated in MD, or sample mean of the different scores, is 1.2 points higher than the photograph with the tattoo, with sum of squares equals 33 for the difference of scores. So the question is, does the presence of a visible tattoo have a significant effect on the attractiveness ratings? Use a 2-tailed test with an alpha equals 0.05. So we know we're going to need a critical value. So the first thing I'm going to do is I'm going to go, I've already marked my page here so I could just turn to it, but you guys, it's on page 651. So the T distribution table, because you know you're doing a t-test. Now we know that degrees of freedom equals n minus 1. And we know, well, first of all, number 6, n equals 12. So if n equals 12, degrees of freedom is n minus 1, or degrees of freedom is going to be 11. All right. So you're going to slide down to number 11 for degrees of freedom. And then you're going to do, because the question told you it was a 2-tailed test at 0.05, you're going to look for 2 tails, 0.05. Come down to 11. Your critical number is 2.201. So I'm going to write down critical value . 2.201. Now, what other information is this prompt give me? It gives me n equals 12. It gives me the sample mean of the difference. I wrote these down so you could kind of know what they were in the symbols. So MD equals 1.2. And then sum of squares is 33. And this is all straight from your book, straight from question 6 on page 360. That all the information is given to you. They don't tell you to use the t-test, but you know that because, like I said, you're only testing 2 different photos against each other. There's not, 3 different scenarios. There's not with tattoos, without tattoos, and then something else. It's just with and without tattoos. So that's 2 things. So you're going to use a t-test. Okay. So now I'm going to think, okay, if I need to do, this is going to be your critical value. I need to see what T equals and see how it compares to your critical value. So what is the formula for T? Well, if you look back in chapter 11, which is where this question came from, on page 341, T equals the sample mean of the difference minus mu d, which of course mu d is going to be 0 because you're basically, in your null hypothesis, it's 0, and that's what you're comparing it against. So the or as the book says, it says the sample data are represented by the sample mean of the different scores. The population parameter is the value predicted by null, which is MD equals 0. So you know that this is going to be 0. But the denominator of this equation is your estimated standard error, which is SMD. So that's your equation. Now we don't have all of these values, so what are we to do? And this is how I start all of the problems. I write down what I do have. I write down what I'm trying to get to and see what I need. So I have this. So we know the numerator is going to be 1.2 minus 0. So 1.2. So you don't have this. So now I know I need to find this. And so if you look back on page 342, you see that that equation is there for you. The square root of s squared over n, and you now have another value that you don't have, s squared, or the variance. So you know n is 12, but we don't have s squared. So now I'm like, okay, well, how do I get s squared? Well, look back at 342 again, and it tells you that s squared equals the sum of squares over n minus 1. And we have all those numbers. So we have 33 over 12 minus 1, which equals 33 over 11, which equals 3. So your variance is 3. Put your variance here into your estimated standard error, and you've got the square root of 3 over 12. 3 divided by 12 is 0.25, and the square root of 0.25 is 0.5. So that is your estimated standard error. That's going to go in your denominator here, so 0.5. So 1.2 over 0.5, let me pull up my calculator. 1.2 divided by 0.5 is going to be 2.4. Now, your t equals 2.4. You're going to compare that to your critical value. So our value is greater than 2.201. So it's in the tail. And just remember that, easier way, I'm visualizing this in my head, but just so that, make sure that y'all are visualizing the same thing. Your critical values, so we said it was 2.201. So it's 2.201, and then over here it's negative 2.201. That's your critical values. This is where you reject the null hypothesis and you say that the treatment, whatever it may be, has an effect. So your 2.4 is in the tail here, and that's in the critical region. Okay, so this means you reject the null hypothesis that there is no difference. So the question asked you, does the presence of a visible tattoo have a significant effect on the attractiveness ratings? Well, since it's in the critical region, yes, it does have a significant effect on the attractiveness ratings because we are rejecting the null hypothesis, which is that there is no difference. So hopefully that will help you. And I try to lay this out, and I've been doing this on your quizzes. I try to lay it out to where you know which values you're looking for. You just have to find these formulas. And honestly, I keep these formulas written down in a list, and that way they're all handy. And you can try that too. Maybe as you go through the chapter, write down the formulas that you need, and that way when it's time for you to take your quiz, you have everything sitting right there. So if anybody has any questions about this, this is just one of the type of question that you're going to see on your quiz. I will do another video for the other one because I have to find another similar question. I don't like to make up a question that I can't guarantee that the answer is correct. So I typically look for questions instead of make them up. So if you need any further assistance with this, or if you have any specific requests for a type of problem that you would like me to work out, I can't work out quiz questions until the end of the quiz, until everybody's taken it, but I can do that if that's something that anybody would like me to do. So just let me know if you have questions.